All right, proceeding to section 3. This section is about integer type question where you got to solve the values. You'll not be getting 4 options like the previous cases. You have to solve it and you would be getting one answer which lies between 0 to 9. And there are 5 questions in this particular section. And for correct answer, you would be awarded 3 and there is no penalty for negative marking. Now let's see. The first question of this section is taken from radiation. A metal is heated where a sensor is kept above the metal. So probably the metal is heated on the furnace and above the metal a sensor is kept which detects the power. To read power radiated. The sensor has a scale log base 2 P by P naught where P is the power radiated and P naught is constant. Together here emissivity of the metal would be assumed to be constant. Normally what happens is that for non-black body emissivity changes with temperature, but here in the question it was written that the emissivity doesn't change with temperature. That's the assumption that we got to carry with. Now at 487 degrees centigrade the sensor shows 1, that means this is the value which is 1, then the reading of sensor at 2767 degree. So first of all the temperature what we require is in Kelvin, so T1 would be 487 plus 273, so that comes out to be 760 Kelvin, that's the first one, and temperature T2 is 2767, that has to be 7. All right, so that's the temperature, the T1 and T2. Here, straightforward, you could see that T2 is 4 times T1. That's the information that we could extract. Now, let's try to see the solution part. The first reading, or let me say the reading to be X. So, X2 is log base 2 P by P naught. And X1, which is 1, because the reading is 1 when the temperature is 487, is log base 2 P by P naught. Let's better write something like this. This has P2, this has P1. Now, what we'll do is say X2 minus 1 is log base 2 P2 by P1. That's a very simple property of log that we can apply. And X2 minus 1 comes out to be log base 2, and we just seen P2 by P1. Since power is directly proportional to 4th power of temperature, so here what we get is T2 by T1 raised to the power 4. So on all those calculations now it's quite simple because this is 4 and X2 would come out to be 9. So 9 is the integer which is the correct option for this particular question, question number 14. Now let's move to question number 15. All right, question number 15 is from the topic nucleus of modern physics. And here is a typical nuclear decay where boron emits a beta particle and consequently a carbon nucleus is also formed. But this time this carbon is something having asterisk. There is a condition, and that is 12,6 C asterisk is excited carbon nucleus at 4.041 mega electron volt above ground. That means a normal carbon nucleus which is at ground state, and this carbon nucleus which is at excited state, the energy gap is this much. Together the mass of boron has also been given, and the mass of carbon, it's a standard 12.00 U. From this particular data we need to calculate the kinetic energy of beta particles. Generally we cannot predict the kinetic energy very easily because it divides into varied fraction, the anti-neutrino also being there. So the question has made everything easier, said maximum. That means we'll be calculating the Q value, and when it is maximum, things are very straightforward. The entire Q value would be the maximum possible Ke. So in this particular regard, what we'll do is say the Q value is the mass defect into C square, and here comes 12.014 minus of 12.000, the regular carbon, the carbon which is in ground, into U multiplied by C square. This would be the normal feature if the byproduct was a ground state carbon. But here the carbon that we have already has an energy higher by this amount, so that also needs to be subtracted. And the whole answer required is in mega electron volt, and this finally gives us the answer 9 mega electron volt. The option had asked the maximum kinetic energy of beta particle in mega electron volt. That would make it more precise and specific and clear. So 9 would be the correct integer for this particular question, question number 15. Now let's proceed to question number 16.